Hi everyone, welcome to video 4 of lesson 2.5, absolute value functions. This video serves as a connection piece between video 3, where it deals with absolute value equations, and we're now going to add a new layer and talk about absolute value inequalities. So one of the first things that I want you to note here again is that absolute value is always going to be describing some sort of distance. Okay, so before you even begin a problem, make sure that it sounds logical or that it makes sense. For example, if I read this example problem that we are going to crack into soon, we would say that we're looking for something that has a distance that is less than or equal to 8. So ask yourself, is that a possibility? Can you have a distance that is less than or equal to 8? And hopefully you're either vocalizing the word yes, or you're at least subtly shaking your head yes. But note, if I were just to add one tiny extra detail, that little red negative sign there, suddenly it becomes a problem that it cannot be done. You literally would just kind of say not possible and walk away from it. Because now the problem is saying, can you tell me something that has a distance less than -8? And since we know that distance can never be negative, this statement or this question doesn't make any sense whatsoever. So let's undo that so that we don't have to look at that anymore. And let's jump right into this problem. So if you recall, when we were doing problems like this before, we had two situations. We had 2x minus 9 being broken into two different situations. So one of them dealt with a 2x minus 9, and it had some sort of relationship with 8. And then we also had another one where 2x minus 9 had some sort of relation with -8. And since we're dealing with inequalities, we need to be careful here. So in this situation, we are going to go ahead and say, well, remember that 2x minus 9 is a number. So we can find some numbers that have a distance less than 8. With regards to anything positive, well, we know that 8 has a distance less than or equal to 8, as do all of these other numbers here. They all have a distance that is less than or equal to 8 when leading up to 0. Now our other example would be 2x minus 9 has to be greater than or equal to -8. And if you notice, all the numbers from -8 leading up to 0, these are all numbers that also have a distance that are greater than or equal to -8. Okay, so we're going to start there. So that's how we've broken up these two cases, and we can actually continue to solve from there, and we can actually do double time. We get to 2 for 1 kind of deal. So as we solve, we would add 9 to both sides. And this is going to give us 2x is less than or equal to 17. And we also get 2x is greater than or equal to +1. Now we can go through and isolate x further by dividing both sides by 2. And this results in x is less than or equal to 17 halves, or we could write its decimal equivalent, which would be 8.5. And then we would also get x is greater than or equal to 1/2, or again, we could say x is greater than or equal to 0.5. Okay, these are our two answers, but we need to do a little bit more work. Okay, remember how when you've worked with inequalities in the past, there were 3 different ways that you could present your information. You could present them either in inequality form, in interval notation, or you can use a number line. I'm going to use a number line to kind of connect all 3. So all right, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to go ahead and plot this. So when I plot this, I'll find 8.5 I'm going to use a closed circle because of the inequality that we're using here, less than or equal to. And I know that I want to shade to the left. If I take a look at the second inequality, I'm going to find 1/2. And again, it gets a closed circle. And this is telling me to shade everything to the right. My true solutions, or my true answers here, are where my purple and my green lines overlap. So it looks like anything and everything in between 0 and 9, or sorry, not 0 and 9, 1/2 and 8.5, those values included are solutions. So if we were to do this, or do this right up in interval notation, we would say, well, our smallest value was from 1/2, and our largest value was at 8.5, and we want to include them, so we're going to use brackets here. Okay. If we wanted to write this in inequality form, we would say our x value is going to be between 1/2 and 8.5, inclusive. Hence the reason why we're going to use less than or equal signs here. These three items, so visually, the visual, the interval notation, and the inequality notation are all saying the same thing. So let me justify to you why we wouldn't use values outside of that fuchsia shaded area. Okay. Say I pick, we're going to go ahead and we're going to do a check first, sorry. Okay, I'm going to pick something in between 1/2 and 8.5. I'm going to go ahead and I'm going to pick, let's say 1. So I'm going to go ahead and, again, here's my original absolute value inequality, and I'm going to let x equal 1. So I'm going to do 2 times 1 minus 9 is less than or equal to 8. This is going to result in 2 minus 9 is less than or equal to 8, which gives me the absolute value of -7 is less than or equal to 8, or, as we can see, 7 is less than or equal to 8. This gives me a true statement. So that means that the values that you pick in between 1/2 and 8.5 are going to give you true statements. So let's play devil's advocate and say, well, what happens if I pick something all the way to the left? So something outside of that shaded area. For my sake, I'm going to let x just be equal to 0. I think that that's going to be a quick, nice check to work through. Okay, so if I do that, I'm going to have the absolute value of 2 times 0 minus 9 is less than or equal to 8. Doing that multiplication, I'm going to get 0 minus 9 is less than or equal to 8. Simplifying it further, I get the absolute value of -9 is less than or equal to 8, or 9 is less than or equal to 8. This should be cause for concern because that's not true. That's a false statement, so no, this is not possible. Okay, so let's continue along. And again, playing devil's advocate, let's say that we pick something somewhere outside of that shaded region on the right side. So I'm going to do x is equal to 10. And if I do the absolute value of 2 times 10 minus 9 is less than or equal to 8. Let's see what happens. Whoops, sorry about that. So 2 times 10 is 20 minus 9 is less than or equal to 8. 20 minus 9 is going to give me the absolute value of 11 is less than or equal to 8. And the absolute value of 11 will still result in 11. And it gives me 11 is less than or equal to 9. Again, this is worrisome. Like, what? It doesn't make any sense. So again, not possible. This is false. So again, this justifies, or helps to justify, why the only true solutions that you are going to have are going to rest in between 1/2 and 8.5. Now, mind you, as well, just as a final check, if you pick any of those numbers, they will also work. So if we did x is equal to 1/2, for example, if we did 2 times 1/2 minus 9 is less than or equal to 8. This results in 2 times 1/2 is 1 minus 9 within the absolute value. This is going to give me the absolute value of negative 8 is less than or equal to 8. Absolute value of negative 8 is positive 8. And as you can see here, 8 is less than or equal to 8. That is a true statement. That should make you happy. So, that is all. Thank you very much for watching through all 4 videos. If you do have any questions, again, please message me.